All right, really quickly, what I'd like to do is go over the function for Numpy that looks like this. So it's basically like a concatenate function. And let's first import Numpy. And we're going to create two quick arrays. We'll say x1. So think of these as rows in a spreadsheet. We have a spreadsheet that's got a column and rows. We're going to pull some of this data and we're going to add it together in different ways to show how to use this concatenate. Let's start with one row of data. We're just going to create a Numpy array here, and we're going to put 2, 5, let's do 450. All right, and so now we have this array, and we can view it really quick. X1 is literally an array of those numbers, and we're going to create one more array. All right. Now we have two arrays. If we just did something like this, you'd see you have two separate arrays, two different objects that are each an array. Now, usually you have rows kind of stacked on top of each other. So to do that, we can really quickly just say, we'll create this object called data, and it'll be another array where we'll have an array of arrays. So we'll have multiple arrays in a row. So we're going to do this. And what we're doing is we're basically creating a spreadsheet type of data object. So let's call data. And you can see here now you've actually got an array of 2, 5, and 450 with a comma and then another array. And all of that is in brackets, which makes it an array of an array. And Jupyter Notebook automatically kind of assembles that for you in the spreadsheet field. So you can see your first array is a row, and then X2, the second array we created, is another row. So we have two rows, and as you get rows, you automatically start to have columns. So as you can see, in order to add rows, you literally can just create a bracket and add your different rows in there. Creating a column is another story. In case this isn't quite clear how this is coming together, I'm going to do one more thing maybe to make it a little more clear. Let's give each column a name. We'll say the first one is people. Let's consider we're looking at houses, rooms, and square feet. And then we can, we're going to create something called a data frame, which is basically a spreadsheet. We're going to create a data frame, and we're going to use our data object, which is our array of arrays, and the columns are just going to be the features. So again, we've got rows. This is row 0, which is the first row. Row 1, these are the indexes. We've got how many people can fit in it, how many rooms it has, how many square feet it has. And we start to build this kind of spreadsheet of data. So let's say though that you had another, we call them features, another column that you wanted to add. How would you do that? And this is where the function that we're going over comes into play. So let's create something called feature 4, right? Our first feature is people, our second feature is rooms, and our third feature is square feet. Let's say that we've done some data analysis, we've pulled some more figures, and we want to tack on this fourth column. And so we'll create another array in this case, and we'll just put 1, 2, nothing complex. It'll help us find it quickly. And this is where the this concatenate feature comes in. So you create a new object, updated data, and we're going to do mpc underscore, and then all you do is put in there your original array of arrays, and then you add in this case feature 4. I have features 4. And now when we look at this updated data, you can see that we have gone from where it's 2, 3, 5, 6, 450, 950, we now have a fourth, which is 1 and 2. This also will change the original array. So if you look up here, the original array was only 3. So now if we pull updated data 0, which is the 0th index, you can see that this array is now longer. All right, and that's really the main purpose of C. The question is, when would you use this? Well, there's two main places that I use it. If I have data such as this here, these rooms, and I'm running some kind of regression analysis, I might use it to add my bias feature. So to do that, I would create a bias array, and if you're a little fuzzy on what the bias is, if you remember, we've got this thing that says, let's go down here, y equals mx plus b. That b actually stands for bias, right? So this is how much we're going to weight x to help us predict y. That's what m is, also known as the slope. But b is the bias. It's kind of the initial starting figure. It's where we can move our weights up or down to help us get more accurate version of y. This bias is basically just a constant. And so if we have a number of x's or features, in this case we've got people, rooms, square feet, and we want to shift that, we want to move that, then we need to have a bias array that we can also adjust and use in our regression. And so let's go back here. We're going to go to the bias array, and we're just going to create a starting point. So we want 2, 1, and this is going to give us an array of arrays. So basically you can see we've got this column we want to add. Now to add that column, we can just take our updated data, or you can even just do our original data, and we're gonna add in our data with the bias column is going to be, we can add in our bias right up front, and add in our data. And now you'll see data with bias. We've got our bias right here. So again, these will be weighted, based on when you do your regression, but this is going to be kind of the baseline bias feature that we can add right into our data, so we don't have to do them separately. The other time that I use it, and this is actually more often when I use it, is when I'm building a pipeline and pre-processing data. And so let's say you've got some kind of data, these are all numbers here, but let's say you've got data that says whether or not it's an apartment or a condo, and so you've got, let's put in an x3 here, actually, let's be feature 5, and you've got a 1 if it's an apartment, and 2 if it's a condo, 3 if it's a house. In this case, we've got 2 of them, so let's do something like this. We've now got this 5th feature that tells us if it's, in this case, an apartment, a condo, which it isn't, or a house. And when you pre-process this is called categorical data. It's category. Up here, we've got our actual numbers and figures. So these are all numerical figures. In other words, as the square footage gets higher, this number gets higher. They're directly related. The number of rooms, as this number grows higher, the number of rooms actually grows higher. As this number grows higher, it has nothing to do with anything getting higher, right? It's just representing a category. So these are going to be pre-processed differently. So often what you'll do is you'll split the data. If your original data has got it all together, you're going to split feature 5 off, and you're going to pre-process it differently than the way you pre-process actual numerical data. At the end, in order to build your regression, you're going to have to put them back together. And so that's where I use it a lot is, when I've finished, I'll pull in the original data, pre-processed, clean, all the empties filled in, my outliers adjusted, whatever I'm doing to pre-process it and get it ready to build my regression or my category analysis. And what I'll do is I'll then put it back together in here. So I'll say, okay, this is data with the bias. And then I also want to add in my pre-processed categorical data, which will be processed differently. So basically I'm splitting them and I'm putting them back together. And when I'm done, I'll have all my data back in one clean format to use for my regression analysis. So again, I just wanted to kind of show you this NPC, what you can think of as kind of a concatenate. What it actually does is it adds or concatenates on the second axis. So the first axis is the rows. So as you can see, if I just put a comma and add this, it adds it on the first axis. It adds another row. The second axis is the column. And so if you can see when I use this, it adds whatever my data that I have in here on the second axis. So that is the technical definition of what the C underscore does, which is a sublibrary of Numpy. All right, I hope this was somewhat helpful just to get an idea of what this does, why it's used. If you see it in examples and tutorials, that's all that's happening.